All right, guys, this is our lesson on areas and volumes, just kind of a general geometry, area, surface area, etc. So we're going to start with these kind of composite shapes. This one right here can be broken up into a half circle and a rectangle. So the rectangle is easy. It's just length times width, and the length and the width are 6. So I'm going to call that area 1, or why don't we call it area of the rectangle or the square is equal to length times width, which is 6 by 6, which is equal to 36 centimeters squared. The area of our half circle is going to be equal to pi r squared. So that's 3.14 times, what's the radius of that circle? Well, that's from the middle of the circle to the outside. So if that whole length is 6, it's going to be 3 centimeters, and that's squared. So I take my pi button, or you can use 3.14 times 3 squared equals 28. That's square centimeters. And that would be for the full circle. So we want to divide that by 2 because it's just a half circle. So I go divided by 2 and it tells me it's 14 square centimeters. So you add that and that plus 36, it's 50. So my total area is equal to 50 square centimeters, and done. Part B, again, I believe I can break it into a rectangle and this time a triangle on it. Length times width in here, and base times height divided by 2 for the triangle. The length and width of the triangle, I'm going to have to figure that out, aren't I? Because it's 5 centimeters there. This is going to take some doing, actually. This is going to be 3 here. So we can figure out the height of this because of Pythagorean theorem. I've got 5 and 3. So remember, Pythagorean theorem is c squared equals a squared plus b squared. So we're solving for like b or a in this case. So that's going to be b squared, let's say, is equal to c squared. That's going to be 5 squared minus 3 squared. And in the end, you get a side length of 4. 5 squared is 25, 3 squared is 9, 25 minus 9 is 16, and then the square root of 16 is 4. So that tells me that this side length right here is 4. So that's important, right? I'll write my length times width here again. So the area of the rectangle, length times width, is going to be 5 centimeters times 4 centimeters, which is equal to 20 square centimeters. Done. It's the area of my rectangle. The area of my triangle is equal to base times height over 2. And in this case, that's base and height are 3 and 4. So that's 3 times 4 over 2. That's 12 divided by 2 is 6 square centimeters. Add the 6, add the 20, and you'll get a total area of 26 centimeters squared. I don't like that. Centimeters squared. There we go. Moving right along. You may remember this. This is an example I used earlier in the course, and it says determine the area of the shaded region. There's just the shaded region. So what you do is you imagine you have the area of a big half circle, and you subtract the area of the little half circle. All right. The big half circle, the base, no, not base times height, pi r squared. And since it's a half circle, I'm going to include divided by 2. And I'm going to put big for big radius minus pi r squared for the small radius over 2. So away we go. The big radius is 8 centimeters. So pi times 8 squared divided by 2. Remember, the divided by 2 is because of the half circle. And the radius is from the center of the circle to the outer edge of the circle, which it shows clearly is 8 centimeters. Minus pi. Now, what would be the radius of the small circle? if the big circle has a radius of 8 and my little shaded area has a length, I want to say, of 2, then that means the small circle has a radius of 6. Now, this can all be typed into your calculator in one step, I think. So I'm going to go pi, or 3.14, times 8 squared divided by 2 equals, and that's 100 roughly, minus pi times 6 squared divided by 2 equals, and in the end I got about 44 square centimeters. It was 43.9 something, but 44 square centimeters. Pause the video if you'd like to punch that into your calculator and see if it works for you. Next one says the circle shown has an area of 500 square meters. Determine the radius and the circumference. That's exciting. So remember, the formula for a circle is pi r squared. But up until now, we've only been solving for area. This time it wants us to solve for radius. It tells me that the area is 500 square centimeters, pi r squared. So first thing you got to do is divide both sides by pi. That gets rid of the pi. And 500 divided by pi, or 3.14, is equal to 159. So I got 159.15 and some other stuff is equal to r squared. The last step will be to square root it because it's r squared. So I hit my square root and I find the radius is 12.6 centimeters. So that's the radius, done. It also says find the circumference, and you haven't seen that yet. It's 2 pi r. That's the formula for circumference. Now that we know r, we can easily put that in here and finish this off. It's 12.6 centimeters. So I go 2 times pi times 12.6, and it equals 79. And circumference is a length around the circle. So that's just straight centimeters, okay? That's that one. A metal disc has a radius of 12 centimeters shown. A smaller circle is to be cut from the center of the disc so that the circle and the ring formed, the cut circle and the ring form, have equal areas. What is the radius of the smaller circle? Okay. So first thing I would recommend we do before we even think about the solution is find the area of this circle. Pi r squared, which is equal to pi times 12 squared, which is, give me a moment, pi times 12 squared is equal to 452.39. 452.39 square centimeters. So if we want to cut a piece out of the middle that has the same area as what's left over, then we have to divide this area by 2. That's the only way to cut this area out and have 2 equal parts, is to divide by 2. So it's 452.39 divided by 2 is 226. I'm going to round, okay? So 226. We know we want the smaller radius to give us an area of 226. That would be square centimeters. So a equals pi r squared. In this case, it's 226 equals pi r squared. Divide by the pi, just like we did before. So I go 226 divided by pi, or 3.14, gives me 72 equals r squared. Square root, and I get 8.5. R equals 8.5 centimeters. That's the radius of the cutout, so that the radius of the small cutout and the radius of the ring left over have equal areas. That's homework from before. I have a little bit of worksheet. I have a worksheet that I have posted to go with this. One more little thing to work with some more composite objects. Right here. There we go, working with composite objects and even three-dimensional shapes. It says calculate the volume and the surface area. Let's get this into presentation mode. So the volume of a cylinder is the area of the circle, so pi r squared, times the height of the cylinder. So it's the area of the circle on top times the height. So that's going to be pi times 4 squared times 10. Pretty simple. Just pi times 4 squared times 10 equals 500, and I'm going to round it to 3. 503 cubic centimeters. Now, the surface area is a little trickier because there are two circles to find the area of, one on the top, one on the bottom. So it's going to be 2 times pi r squared because there's two circles. Circle is pi r squared, and there's two of them, so I multiply by 2. Plus, it's the area of a rectangle that goes all the way around. This rectangle right here, length times width. But the length is the height. Or the height can be the width or whatever. The width would be from here to here. And then the length of it would be that distance around, which is equal to what? The circumference of the circle, which is 2 pi r, as you saw in a previous example. So it's going to be plus 2 pi r, I'm going to say times the height again, because the height and the width are the same thing. So that's going to be 2 times pi times the radius squared, that's 4 squared, plus 2 times pi times 4 again times 10. Made my 1 a little big there. 2 times pi times 4 squared, plus 2 times pi times 4 times 10. It equals 352 squared centimeters. If I add all those up. Pause the video, check the calculation if you'd like, and that'd be just fine. Now, I don't even know the reason for this, but the volume for anything that comes up to a point, like this cone shape, it's equal to the area of the base, so the area of the base being a circle, pi r squared, times the height, just like with a cylinder, but divided by 3. That divided by 3 is because instead of coming up like this, it goes into a point. And we'll just focus on the volume of this shape right here. So pi times 4 squared times 10 divided by 3. Pi times 4 squared times 10 divided by 3 equals 168. 168, and is this centimeters? Yes, centimeters. 168 centimeters cubed. Cubed. That is how you deal with a cone. Now, the title of this was composite shapes, and neither of those were composite shapes. It was just a review of a couple of three-dimensional figures. So, determine the volume and the surface area of this. So the volume's not too bad. It's a triangular prism in a box, all right? So for the box, you just go length times width times height. First, we're going to focus on the volume first. So the volume is going to be equal to 14 feet by 9 feet by 7 feet. Oh, I don't like it when that happens. 14 feet by 9 feet by 7 feet high. That'll give me the volume of the box part of this. 14 by 9 by 7. 882. We got to add the volume of that triangular prism. So the volume of it, again, will be the area here times by this, quote unquote height. So 14 will be what we put in for H, and then the area of the triangle, or the length of it if you prefer. It's just like how the cylinder works. You find the area of the base, multiply it by the height. So in this case, it's going to be base times height over 2, that's for the base, the triangle shape, times 14, or times whatever that is. So the volume here will be equal to 9 times 3 over 2. So that's 9 here times 3 here over 2. That's the area of the triangle, times 14 to multiply it through that volume. 9 by 3 divided by 2 times 14 equals 189. And both of these would be feet and cubic feet. Add them together, and you've got your answer. Plus 882 equals 1071. So the total volume is equal to 1071 cubic feet. That's how you find the volume of that shape. Let's also do the surface area. Why not? Pause it here if you want to write anything down or check any of my calculations, because I need space, so I got to erase all this stuff. It's all going away. You can always go back and see it if you want to see it, but for now, it's going to disappear. So for the surface area, what do I see here? I see a face here, and there's going to be a face in behind that matches it, and there's going to be a face on the side, and there's going to be one on the other side that matches it. So how many sides to that box? Well, there's going to be 4, and then it just says the shape. If this was a house, you wouldn't count the bottom, but it just says a shape. So let's find the volume of the bottom, or the area of the bottom as well. So for the box, there's going to be 5 sides that we include. 1 on the bottom and 4 around the outside. So it's going to be 2 times 14 times 7. So that takes care of this shape and the one opposite on the other side. 14 by 7, because that's 7 right there. Plus 2 times the front face is 7 by 9. 7 by 9. And I'm going to add one more thing, but I'm not going to multiply it by 2 because it's just the bottom. It's going to be 14 by 9. 14 long by 9 wide. And I can type all that in. So this is the surface area just for the box shape. I'm not including the top because there's no surface exposed there. So I go 2 times 14 times 7 plus 2 times 7 times 9 plus 14 times 9, and I got 448. 448, and that is feet. That is square feet. So that's for the bottom of the box and 4 sides around the box. Now for the triangular shape, the surface area is going to include 1 here and a matching triangle on the back, and then 2 rectangles. 1 rectangle here and 1 that you can't see that matches it on the other side. So there's 4 shapes there, but they match each other, so we'll just multiply by 2. So for the 2 triangles, I'm going to go 2 times base times height over 2, plus 2 times length times width, because there's going to be 2 lengths and 2 widths. So the surface area is going to be 2 times, what's the base and height of the circle? Same as before. It's a 9 by 7 over 2, plus 2 times, what's the length and width of that box shape? I'm going to have to do a calculation as an aside, because I have 3, I have 9, I don't have this side length that I need right here. So to find that length, I'm going to go like this. I've got 3, I'm going to make it into a right angle triangle with 4.5 as that bottom part there, because the whole distance was 9. So let's go ahead and do that. Pythagorean theorem is, c squared equals 4.5 squared plus 3 squared. So I go 4.5 squared plus 3 squared equals, and then take the square root, and it's 5.4. 5.4 feet, 5.4 feet. So there, I can finish this off now. So the length of that rectangle is the 14 feet. But now I know that the width or whatever of that rectangle is 5.4 feet. If I type all that into my calculator, that'll give me the surface area of that triangular shape. We're not going to count the bottom because it's not exposed. So away we go. 2 times 9 times 7 divided by 2, 63, plus 2 times 14 times 5.4. And it gives me 214 square feet. Got to take that, add it to that, and that should give us the answer, 448. And it gives me 662. So my total surface area is equal to 662 square feet. That's how you do it. That's how you deal with a composite shape. We're going to leave it at there for now. To test you on this, I'm not going to give you this assignment again, but you might have nightmares about this assignment, about the barn and the silo, and you had a bunch of questions on that. I have just some simple composite shapes for you guys to work out. And that'll be that. All right, guys. So I think that's it for now. And good luck with that. Of course, email me or use the comments in Google Classroom. All that comes straight to my phone if you have any trouble with this stuff. And good luck.